Sometimes when our trigonometric function isn't in the right form to integrate, we can use a trigonometric identity to get something that we know how to integrate. So sine squared x and cos squared x, we can't integrate in that form, but we can use a trigonometric identity, and that is our cos 2a. So we know that cos 2a is either cos squared a minus sine squared a, or 2 cos squared a minus 1, or 1 minus 2 sine squared a. So to integrate sine 2x, we use cos 2a equals 1 minus 2 sine squared a. So let's write this down. So cos 2a, or cos 2x, is 1 minus 2 sine squared x. Rearrange that to get sine x by itself. So plus 2 sine x to both sides. Take away cos 2x, and then half both sides. So sine x is half of 1 minus cos 2x. So now we can change the question. So we're integrating half of 1 minus cos 2x. We can even take the half outside. So when we've got a constant, we can either leave it in our integrand, what we're integrating, or we can take it outside. And then we can just integrate it. So what are we going to get? I'm leaving the half on the outside. 1 integrates to give x. A cos would integrate to give a sine. And we're going to divide by the bracket differentiated. So dividing by 2 or timesing by a half. So minus a half times sine 2x and plus c on the end. Part B, we've got 2 sine x cos x. So when we've got a sine and a cos multiplied together, we integrate it using our other double angle, our sine 2a. So sine 2a, or sine 2x, is 2 sine x cos x. So we can see x is changed into 3x here. So 2 sine 3x cos 3x is the same as sine 6x. So sine integrates to give a negative cos, and we divide by the bracket differentiated, which is 6. So it's minus a 6 cos 6x plus c. So if we differentiate this, a cos differentiates to give a negative sign, times by the bracket differentiated, so we get sine 6x, which is the same as 2 sine 3x cos 3x. 2 for you to try. See if you can give these a go. So for the first one, we've got cos squared x. So we're going to use our cos 2a. So cos 2a is 2 cos squared a minus 1. So cos 2x is 2 cos squared x minus 1. Let's get cos squared x by itself. So plus 1 to both sides and half both sides. So we're going to integrate half of cos 2x plus 1. And we can leave the half on the outside. Integrate cos 2x. That becomes half sine 2x. So cos integrates to give sine. And we divide by the bracket differentiated. 1 integrates to give x. And we plus c. Sine x cos x, we're going to use sine 2x. So sine 2x is 2 sine x cos x. So half of sine 2x is sine x cos x. So we can't integrate sine x cos x, but we can integrate half of sine 2x. Sine integrates to give a negative cos, and we divide by 2. So it's minus a half cos 2x plus c. Tan squared x. So we don't have a way of integrating a tan squared x, but we do have another identity that we can use. So remember we had cos squared x plus sine squared x equals 1. If we divided through by cos squared x, we get 1 plus tan squared x equals sec squared x. So tan squared x is the same as sec squared x minus 1. So we're going to integrate sec squared x minus 1. And we can integrate that. Sec squared x integrates to give tan x. So we're going to integrate it. We get tan x plus, tan x minus x and plus c on the end. Sine x squared cos x squared. There are different ways of getting this into a form we can integrate. I am going to change it into sine x cos x all squared. And sine 2x is 2 sine x cos x. So half of sine 2x is sine x cos x. So I'm going to change this into half of sine 2x squared, which is the same as 1/4. So half times a half is a quarter. Sine squared 2x. I still need to deal with my sine squared. So I'm using my other identity. Cos 2x is 1 minus 2 sine squared x, which means that sine squared x is the same as half of 1 minus cos 2x. So I'm going to change my sine squared 2x, into half of 1 minus cos 4x. So we have a quarter times a half of 1 minus cos 4x, which is the same as an eighth of 1 minus cos 4x. Now it's finally in the right form to integrate. So I'm going to take the eighth out of it. 1 integrates to give x. Cos integrates to give sine. And I'm going to divide by the bracket differentiated, which is 4. So it's minus a quarter of sine 4x. So 1/8 x. 1/8 times x minus a quarter of sine 4x and plus c on the end. Two for you to try, see if you can give them a go. So we have cot squared x, which we can't do anything with. But if we take our identity, our cos squared x plus sine squared x equals 1, and divide through by sine squared x, cos squared x over sine squared x is cot squared x. Sine squared x over itself is 1. And 1 over sine squared x is cosec squared x. So we can change cot squared x into cosec squared x minus 1. Cosec squared x integrates to give it a negative cot. So it's negative cot x. 1 integrates to give x and plus c. Sin x plus cos x all squared. So let's expand the brackets. So we're going to get sin x times sin x, sin squared x, plus sin x cos x, plus another sin x cos x, 2 sin x cos x, plus a cos squared x with respect to x. The sin squared x plus cos squared x equals 1. So we've got 2 sin x cos x plus 1 that we need to integrate. 2 sin x cos x, whenever we've got a sin x times a cos x, we're using sin 2x. So 2 sin x cos x is sin 2x. So we're integrating sin 2x plus 1 with respect to x. Sin integrates to give a negative cos, and we divide by the bracket differentiated. So it's minus a half cos 2x. The 1 integrates to give x, and we plus c. And one more set of questions. So we've got cos 2x over cos squared x. So let's start with our cos 2x. So remember we had cos 2x. It could either be cos squared x minus sine squared x. It could be 2 cos squared x's minus 1, or 1 minus 2 sine squared x's. So the best one to use might be the cos one. So let's have 2 cos squared x minus 1 over cos squared x with respect to x. Divide both terms by cos squared x. So 2 cos squared x over cos squared x is just 2. And then we've got 1 over cos squared x. 1 over cos is sec. 2 integrates to give 2x. Sec squared x integrates to give tan x. And we plus c. One for you to try. See if you can give that one a go. So this time we've got the integral of cos squared x over sine squared x. That's the same as cot squared x. We can't do anything with cot, but we have an identity, which is 1 plus cot squared x equals cosec squared x. So if we take 1 away from both sides, we can change the question into cosec squared x minus 1. Cosec squared x integrates to give negative cot x. Negative 1 integrates to give negative x and plus c.